Hello, welcome to Measures of Central Tendency. So, there are basically three types of measures: the mode, the mean, and the median. So, let's first of all look at how many groups of data there are. So, basically, there is ungrouped data, which is a list of raw numbers. For example, 2, 5, 9, 4, 2, 6. These are an example of ungrouped data. A group data is which is shown in a form of a frequency table. So for example, you'd be having a table in which you'll be having x as the variable and the number of occurrences of x, for example 1, 2, 3, and then the frequency, which will be, for example, 4, 5, and 2, something like that. So this will be a group data. Okay, so now let's take a look at the first central tendency, which is mode. Okay, so mode or modal class is basically the greatest repeating digit in a data. So for example, in this case, in the ungrouped data, you can see that 4 is being repeated twice. So in this case, the mode will be 4. But if two of the digits are repeating twice, for example, there are two 2's, so there will be two modes in this case. So the mode will be 2 and 4. Okay, and in the grouped data, the mode is simply the number which has the greatest frequency. In this case, 5 has the greatest frequency of 12, so 5 will be the mode. Okay, so let's take a look at where more than one digit is given and the raw values cannot be seen. Okay, so in this case, we can see that the gap is not the same. In here, there is a gap of 3, a gap of 3, a gap of 2, and then a gap of 6. So you see, this gap is not the same. If it were the same, we could have simply used the highest frequency, and the highest frequency would have been the model class. But as this difference is basically called the class width. As class width is not the same for each and every one, we have to take out something called a frequency density. So what is a frequency density? Frequency density is basically the frequency of a specific class and its class width. So in this case, in the first case, we have a frequency of 10 and a class width of 3. So this will give us a frequency density of 10 upon 3. Okay, in the second case, this will give us a frequency of 1 because it is 3 upon 3. This will give us a frequency of 6, and this will give us a frequency of half. So in this case, we can see that 6 is the greatest class with frequency density, it is the greatest frequency density, and hence 7 to 9 will be the model class in this case. Okay, and model class can only be 1. So previously we had done that in raw data if 2 of the digits were repeating, so the mod was 2 and 4. So in this case, there can only be one model class. If two are the same, that means that that specific data has no model class. Okay. Alright, now let's move forward to mean. Okay, so mean is basically the arithmetic average of a set of data. So basically in ungrouped data, we have this many numbers. We will have the sum of all of these numbers, 2 plus 4 plus 5 plus 7 plus 9, and divide by the number of values, which is 1, 2, 3, 4, and 5, which will give us 5.4. Okay, so let's take a look at grouped data. So in grouped data, we have this frequency distribution table. So we will use this formula. Sum of the mean is basically equal to the sum of fx upon the sum of f. So first of all, we will take out fx. Fx is basically the multiple of x and f, the frequency. So 0 into 4 is 0, 5 into 1 is 5, 2 into 3 is 6, 3 into 6 is 18, and 4 into 1 is 4. So we take the sum of fx, which is 33, and the sum of f, which is 19. And this gives us 33 upon 19, making the mean 1.737. Okay, now let's move forward to combined mean. Alright, so let's take an example of combined mean. We have a large bag of sweets containing 72 sweets, which has a mass of 85.24, and a small bag which has 24 sweets and a total mass of 282.8. So in combined mean, we basically consider it as 1. We add the total mass and the total sweets. So we say that the total 96 sweets have a mass of 1135.2 grams, and we basically divide the total mass by the total number of sweets, and we get the answer 11.825 grams. So we basically consider both of these things as 1 and take the mean out of that thing. Okay, so now let's take a look at coded data. So for example, I have this set of data. So I can take this as 1, 3, 4, 9, and 13 as it's simpler. So basically what I'm doing is I'm doing x minus 100 from each and every one of them. So the mean of the coded data is calculated. We take a mean out of this set of data, and then to get the mean of this data, we add 100 because we had originally subtracted 100. So we get 106 as the mean of this data. Okay, so basically we get the formula, which is if we subtract something from the mean, we take out the mean of that set of data, and then we add the thing later when we take out the data. Okay, so in the case of grouped data, in the case of ungrouped data, we did this, but if we have grouped data, because in grouped data the mean is sum of fx upon f, sum of f, so in that case we will use this formula in which we will multiply f with x minus b, with the sum of x minus b as well, and instead of n we will divide by the sum of all frequencies. So in group data we will use this formula. Okay, similarly, if we are multiplying something with a group of data, for example a into x, so we will take the mean out of that data and then we will divide it by a. And for grouped data, again, because the formula is sum of fx upon f, so we will multiply it by f and divide it by sum of f to take out the mean, and then eventually divide it by 1 upon a because we had multiplied x with a initially. So both of these things we've learned can be applied at once as well. So we multiplied by a and subtract b, or divided by a and add b. So we will do the opposite when we have taken out the mean. So for example, I did ax minus b and we have ungrouped data, so we will use this formula. So basically I will take out the mean of this thing, whole thing, and then I will add b and then multiply it and then divide it by a. So the mean of ungrouped is taken out this way and the mean of grouped is taken out this way. Okay, so now that we've learned mean, let's go to median. Okay, so median is basically the mid value of a set of data. So for example, we have an ungrouped data which is arranged. So we can basically cut the values and get to the mid value, which is 7, or we can use the formula n plus 1 upon 2. N is the number of values we have. So in this case we have 1, 2, 3, 4, 5, 6, 7. So 7 plus 1 upon 2, which will give us 4. So the fourth value, 1, 2, 3, and 4, 7 is the median of this set of data. So in case of grouped, we will use this formula. So For example, we have a set of data given. So 0, 1, 2, and let's say 4, 5, and 6. So we will use this data. So the sum of f, which in this case is 15, so 15 plus 1 upon 2 will give us 8. So basically the 8th term is the median. The 8th term. So how will we calculate which is the 8th term? So 4 of the terms are here. So for that we will take out the cumulative frequency. So 4, now we have a total of 9, and now we have a total of 15. So 8 lies somewhere over here, because this contains 4 of the pieces of data and this contains the rest 5. Okay, so the 8th piece of data lies over here. So we can conclude that the 8th term is found in 1. So 1 is basically the median of this data. Okay, now let's move forward. Okay, now let's suppose that we've been given a cumulative frequency graph of, or we've probably drawn one, and they tell us to find the median of it. So the median of it can be found simply through the formula n upon 2. So n is basically the total values we have. So in this case we have a total of 200. So 200 upon 2, which gives us the 100th value. So basically we see what value the 100th position is having. So in this case it's around 25. So we will say the median value is 25. So this is how we will estimate through a cumulative frequency graph. Okay, now let's look at the advantages and disadvantages of taking mean, median, or mode. Okay, so now let's take a look at this. So first of all, what are the advantages of a mode? So it is unlikely to be affected by extreme values. So mode is basically the most repeated number. So it is not affected by the extreme values, as extreme values are not very common. Okay, so useful manufacturers need to know this, that what is the most popular styles. So for example, I sell shirts. So the mode can tell me that the red shirts are sold the most. So I will produce more red shirts. Okay, and they can be used for qualitative data. Qualitative data is something that can't be counted. For example, colors. They can't be counted. So it can be used for that. Okay, so the disadvantages is that it ignores most of the values. It only selects one of the values and the rest of the whole set of data is wasted. Okay, now it is rarely used in further calculations. So the mean takes into account every values. It's basically the average. It is most commonly understood as average. Okay, can be used to find the sum of the data values. So we can find the sum of values, because mean is basically the sum of x upon n. So the sum of the data values can be found. Okay, so disadvantages are that it cannot be found unless all values are known. So if we know a couple of values but some of the values we don't know, so we can't take out the mean. But in case of mode, we can we can't find the mode, but the median we can find, as we just have to find the middle value for the median. Okay, so median can be known without knowing other values. Exactly, that you don't have to know all of the values, you just have to find the middle value. And it is not affected by extreme values, because they are firstly eliminated. Okay, it only takes into account the order of the values and so ignores most of them. Okay, so most of the values are ignored. It only takes into account the middle value. Okay, so that was all from measures of tendency. Thank you for watching. Goodbye.